Okay, so first we're going to talk about the topic of unit testing and how that fits in to the software lifecycle. So unit testing is called unit testing because it checks individual units of code work correctly. So just like we saw with the code in the previous video, the code that tested the ceiling light, we just test a part of the code. We don't necessarily test the whole thing all at once. So we decide what output a function should produce for certain inputs and what data should be stored under certain conditions. So we're trying to check for a particular unit of code what is it going to do and what is it storing. And then we write code that will test those things. But as I say, it's often hard to test all of the code at once for a complex application. So often we just test independent units of code. So we're just testing one thing at a time. In the units can in principle be anything, but in object-oriented code, often the units are the classes. So if you think about the Home Hub, we'll test each of the device types and make sure each one of those works, or we might even test individual functions, but often we're testing classes. Okay, so this is a common feature of commercial code. So commercial code often may be updated regularly, and often it might have lots of people working on it, which means that one person might write some code that breaks another bit of code that somebody else has written. Hopefully that won't happen because hopefully the code has been structured well. But what happens in real life then is that often the unit tests are written by someone, and often they're written by a different team from the programming team, because sometimes if you're writing the code, it's easy to just think, oh, well, it's going to work in this way. We're only going to test these things. Whereas in reality, other possibilities may occur, and so it's better often to get a different team to write the unit tests to make sure that they're sort of independent from the code. And then what happens is every time an update or a release of the code is planned, the unit tests are run. So possibly every day, actually. The code, when it's kind of reached the final state, when everybody's happy with it, then the unit tests are run, and it won't be released until all the code has passed all the unit tests, which means that if it fails some, you have to go back and fix it, or possibly change the unit test if circumstances have changed. Okay, so what to test? Well, as I said, even for really simple programs like some of the ones we're looking at, that you can't possibly test every possible set of inputs. So generally the aim of unit tests then, because we can't capture every possible thing that the user could do, generally the aim of unit tests is that you should test every line of code at least once. So if you've got an if and an elif else block, you need to test every possibility in that block of code. So if this thing is true, if it's not true, then something else. If something else is true, you need to test those things. So you may need to run the code multiple times, that section of code multiple times to test them all. If you're testing loops, you have to test them for a few iterations, not just the first one. You should always try and test what are called edge conditions, which is where the code changes behavior. So if you think about a pizza, which is a very simple object really, in terms of our code, it's just a description, it's got a price, and it's got some extras. So the output really changes when you start to add extras. Okay, so if it's just a pizza, you get the description and the price will be they're sort of set up initially. But as you add extras to the pizza, that will change the output. So one extra changes the output in one way, and then having more extras changes the output in another way. And we'll see that. However, a lot of professional code is unit tested, and a lot of professional code has bugs in it still. So even with a comprehensive and well-written set of unit tests, you can get bugs. So it's a necessary step. It's a good way of catching some of the bugs before the code goes out, but it's not sufficient. And because one of the limitations, of course, is it's unit testing, so it tests each unit independently. And if you have two units that work separately quite well or work perfectly well on their own, When you combine them, they may not work together. So that can be a problem, and you may need to do other testing, such as integration testing. But we're not going to cover that here, so that's a bit advanced. So let's finish that video there, and then we'll look at PyTest for doing this testing.